Hello. So before us we have the function f of x is equal to the log base a of x. And what we need to do is find out what the derivative f prime of x, which is equal to the derivative with respect to x of this function log base a of x, is equal to. So this is an interesting question because in the past we've done the derivative of the function f of x is the natural log of x, which is log base e, but let's say we take any number a to be our base. We're finding out, what does that constant, whatever it is, a, what power does that go to become x, right? I mean, that's the question that you're asking. So to do this, I think that we are going to have to look back at some log properties, because from our understanding of the derivative of natural log of x, which is 1 over x, if we put this in terms of natural log of x, maybe things will get simpler. So we're going to have to think about, back to the log property, that the log base a of x is equal to the log base b of x over the log base b of a, where b is some other constant. So the idea is you can put the log base a of x in terms of the log to some other base of x and a through this transformation. B could be 10, b could be 3. It doesn't matter what a and b are. You can make this transformation and it will always be true. So what if we just said that b is equal to e? What if we say that, b is equal to e, then we have that the log base a of x is equal to, well, what's the log base e? Log base e is natural log. Is the natural log of x over the natural log of a. And there's our natural log of x. We know how to take the derivative of that function. And because a is a constant, natural log of a is a constant. So I think that this is going to make things a lot easier. So let's bring this over. Let's say that instead, the function f of x, it's really equal to natural log of x over natural log of a. These are the same thing. Because of our log properties, we know that these are identical. And this is a pretty important thing, at least a pretty important property to know when you're using a calculator, because if you ever have to find the natural log, if you ever have to find the log to some base, to some other base other than e or 10 that your calculator, at least most calculators, I don't think can do, you can always use this property so that on your calculator you only have to use the natural log or log base 10 or the common log to find that answer. But we'll go over that in a different video. So if we say that f of x is natural log of x over natural log of a, which comes from our log properties, then f prime of x is going to be, right, we set up here the derivative with respect to x of natural log of x over natural log of a. And we can bring that a little bit further, because natural log of a, or 1 over natural log of a, is a constant. So that can just be a coefficient. It can come out of the derivative. So we can say that this is 1 over natural log of a times the derivative with respect to x of the function natural log of x. And hey, that's the function natural log of x. We know the derivative of that function. If you don't recall, the derivative with respect to x of natural log of x, this is one of the useful derivatives in my useful derivatives video, is equal to 1 over x. And it's a really interesting derivative that becomes very important when you look at antiderivatives and such in integral calculus, and it's from where you basically derive all of these formulas for exponential growth, but we'll get into that also in another video. But my point is, we can transform this thing into 1 over the natural log of a times the derivative with respect to x of natural log of x. It's just going to be 1 over x. So in the end, we just get 1 over x times the natural log of a. And I'm going to put x there because there's another thing we can do here. We can say that this is 1 over the natural log of a to the x power. That's another log property, but it's not important. 1 over natural log of a times x, or 1 over natural log of a to the x, it's not of huge importance. The idea is that we do have the function for our derivative now, and we can say with pretty good confidence that given f of x is equal to the log with some base a of x, f prime of x is going to be equal to 1 over the natural log of a times x, or 1 over natural log of a to the x. I hope that this was at least insightful into the world of derivatives. This isn't a derivative that you commonly take, but it's really good to know the tools and the kind of manipulation that you do when taking derivatives of new functions for the future. Thanks for watching.